In this video, we will study the hysteresis characteristic of transformer and its practical setup. So in the previous video, we had seen the circuit diagram of our setup where we had a 230 volt single phase AC supply, a step down transformer, the test transformer and the channels X and Y channel which are to be plotted on our CRO. Now as we can see in the practical setup, we are using an auto transformer which will be used as a single phase 230 volt AC supply. Here we are having a 230 volt to 12 volt single phase step down transformer. After that we are having a fuse and our variable resistor for the X channel and the variable resistor for the Y channel. You can see the capacitor on the secondary side of our transformer across which we will be taking the Y channel output. This is our test transformer. It is a 15 volt by 230 volt 1 ampere transformer. Now we will go towards our hysteresis loop which you can see on our CRO. Now you can see that in this particular scope we are having the hysteresis curve. Now the point at which our curve crosses the y-axis, this point is the amount of residual flux which remains in the core when you reduce the magnetic force to 0. Now in order to remove the complete flux from the core, you will be required to apply the magnetic force in the opposite direction. The amount of magnetic force which is required to be applied to remove the residual flux from the core would be equal to this point wherein your curve crosses the negative side of your x-axis. So this will be this particular amount from origin to the point at which your curve crosses the negative of your x-axis will be termed as coercivity, and the point at which your curve crosses the positive y-axis will be known as retentivity. Retentivity is the property of the core which signifies the amount of residual flux into the core. So this is our practical setup wherein we have studied the hysteresis characteristic for this test transformer. For more queries, you can write in below in our comment section.